Hi, darlings. We're going to start looking um, at a pretty fun concept. I like ratio, but we're going to start with ratio, and I'm just going to dive right in. So I want you to keep this fruit in mind. We're going to come back to it after we do our minds on, but I want you to keep this fruit in mind because this fruit is a really great representation of how we can use ratio. So let's start with our minds on. Um, Before we start, I want you to work along with me because I'm going to go pretty fast. I want you to be able to pause the video, solve the problems, and then keep working, and then go to the next part of the lesson so you don't feel stuck. Okay, so if we were doing this in class, we'd be working together on this part, then you'd go work independently on the next part, but be able to come talk to me. Because you can't, I'm going to work through the beginning of all of the questions so that you can see a proper example, and then you can work independently on the rest. Okay. So for this, I'd like you to have a handful of coins, dimes, nickels, quarters, if you have them, and a pen and pencil or the worksheets that I've given to you. You can print those off and have them with you so you can work through them with me. So let's start. Here's Connor. Here's our pal. He has 5 nickels in one hand. This is his left hand. He has some dimes in the other hand. We don't actually know what the number is in the other hand, but we're given a little bit of criteria. Now, unfortunately, Math Up has made the wording a little confusing. So I'm hoping that I can help to clarify. What they're doing is they're telling us some clues as to how to guess the number that's in his right hand. So we know that he has 5 here. 5. I'm going to write the digit on top. He's got 5. And the first clue is that in the second hand, on his right hand, he has more than 2 times as many dimes as nickels. So what that means is if he has 5 coins in one hand, the other hand has 2 times and then a little bit more. More than 2 times. Okay. So let's look at what that means. We have 5. And what's 2 times greater than 5? Why are you writing that, Miss Wilson? Hold on a second. I had too many little stylus things open. So if we have 2 times as much as 5, we can essentially see that 2 groups of 5 is 10. Okay, and then the next clue says he has fewer than 3 times as many dimes. So let's look. We have 3 times, and we know 5 times 3 is 15. Now they're telling us that answer 1 or option 1 is bigger than this, and option 2 is smaller than this. Okay. So let's think about what options we have here. If he has 5 coins in his left hand, the next hand has more than 2 times. So it's bigger than 10, more than 2 times as many nickels. Okay. And then it has fewer than 3 times as many dimes as nickels. So it's less than 15 and bigger than 10. Okay. Well, then let's look. If I'm quickly draw a little representation, but I want you to think about let's look at the question. How many dimes might he have? Let's do some thinking. Okay. I've drawn a little representation here of his nickels, 5 nickels, and what it would look like if we had an equal amount, okay, of dimes. An equal amount of dimes would be 5 dimes and 5 nickels. So we would have an equal number of nickels to dimes, okay? But we know that we need to have more than 2 times. So I'm going to make 2 times the amount of dimes. And I'm writing my example specifically in this way so that you can see sort of a clear division between my nickels and my dimes. It's pretty clear. Okay. I'm going to write a digit here. 5. Okay. We've got 5 nickels. Now we have 10 dimes, but that's not quite what I want. I want more than 10 dimes. We want it more than 2 times. So this is 2 times. If I add an additional dime, 1 additional dime, now I have more than 2 times. So that makes me sitting with a grand total of 11 dimes. So how many dimes might Connor have? Well, he might have 11. And And then how many coins would he have altogether? Well, 5 nickels and 11 dimes, 16 coins altogether. Okay, well, he might have that. He might also have 12 dimes. Could he have 12 dimes? Yeah, he might have 12 dimes. 12 fits the criteria. If he has 12 dimes, then he's going to have 17 coins altogether. What other options can you come up with? I want you to pause the video. I'm going to pause mine, and I want you to see what other options you could come up with. Okay, so the other two options are he might have 13. That still fits the criteria. It's still less than 15 and bigger than 10. And then he would have 18 coins in total. So that's this one. And then he might also have 14 coins. He's not going to have 15 coins, though, because he's got fewer than 3 times as many. Okay. So you can see that they were kind of building together at the same rate. Okay. That's the end of our minds on. Next, we're coming to this beautiful visual example of some of the important pieces to learning how to talk about ratios. So when we talk about ratios, what we're doing is comparing two different things. In class, I might bring people up so that we could look at like different shoes, or like left-handed versus right-handed, or I don't know, people who like soccer and people who like hockey. Like maybe we could compare people like that. Because I don't have people, I do have pictures of fruit. So we're going to use pictures of fruit to look at these different terms. We can compare things kind of two different ways. We can compare part to part, so part of the picture to another part of the picture. We can compare part of the picture to the whole picture. And then we can reverse those. So we can also compare the whole picture to different parts. So a useful first step is going to be actually counting how many pieces to this we have. So I'm going to pause the video and I'm going to actually count and number all of the different fruit in my picture. Okay, my beautiful penmanship. Okay, so let's look at some different things here. Really, there's no like beautiful right or wrong answer to this. That's not true. Yes, there is. There is a right or wrong answer. I don't know why I said that. But there's no like magic to this. There's a lot of counting. So when we look, let's start with part to part. So let's choose two parts of our picture. I'm going to choose the apple part and I'm going to choose the orange part. So let's compare apples to oranges. I'm going to choose red to show the apple number. So I've counted my apples and the grand total was 6. And that's number 6 over here. So I've got 6 apples. And when we write a ratio, we put those 2 little dots. That shows that it's a ratio. And let's count how many oranges we have. I'm going to go to my orange. Got 1, 2, 3, 4, 5 oranges. So if I compare apples to oranges, I go at 6 apples versus 5 oranges. So 6 to 5. That's another way we can say it. 6 to 5. Okay. Now, if I were to compare oranges to apples, I'm asking about oranges first. It's actually going to look different. If I'm comparing oranges to apples, I'm going to put the orange number first. Then I'm going to put the apple number second. They are different. They are not the same. If we're comparing oranges to apples, the oranges comes first. Whatever it's asking you about comes first. So 5 oranges to 6 apples. That's different. Okay. Let's look at comparing oranges to lemons. Okay. We know we have five oranges. I already know that. Oh, my pen's the wrong color. That's important to me. I wish it wasn't, but it is. Okay. I said oranges first. Okay, so we've got 5 oranges. And we're going to compare them to lemons. 5 oranges. Oh, I've got 3 lemons. Good. So that's 5 to 3. 5 oranges versus 3 lemons. Cool beans. Okay, now let's start looking at the whole to part. Now I used the color blue to show the whole, and I counted the whole group of fruit, whole collection. So in my class, we have 22 students. That would be the whole, 22. And if we compared the grade 6s to the grade 5s, there's some ratios. I would have, can I write over here? I do. I've got 6 grade 6s compared to 17 grade 5s. Okay, look, Miss Wilson, look at this good idea. If I were to compare my grade 6s to the whole class, I would say I've got 6 versus 22, 6 grade 6s to 22 students. And if I were to compare the whole class to the number of grade 5s, 22 kids in the whole class versus 17 kids in grade 5. If I were to compare the whole class to grade 6s, it would look a little something like that. 6 grade 6s. And if I were to compare the grade 5s to the grade 6s, grade 5s to the grade 6s look like that. Now, if I went even further, and normally I don't like to do this, but here I am, I'm going to do it anyway. No, I'm going to do something different. In my grade 6 class, we've got 6 kids. I know that during Ramadan, 3 of them were fasting and 3 of them were not fasting. And if we keep thinking about Ramadan, I know that I had 3 students fasting out of the total 6 grade 6s. Another ratio. So we're comparing a part of the group to the whole group. If we look at my grade 6 group numbers here, we can see some good comparison. Okay? It's easy to compare when we have our digits like that. I can tell easily looking at this number that I have way less grade 6s than I do grade 5s. And then out of the whole, I've got far fewer. Okay. If I'm looking at my fruit, if I go back to my fruit, I got really distracted there. If I go back to my fruit, I can compare. I'm just going to do one comparison because I bet you guys are catching on. I can compare my whole to the part. So let's compare all of the fruit to how many lemons we have. We've got 14 pieces of fruit to 3 lemons. Are you guys getting it? You get it? You feeling good? If you don't get it, let's pause it. Let's send Miss Wilson a message. Go to Khan Academy. Sit with it. Come back, rewatch. Try again. Otherwise, I'm moving on. Going to the next screen. Okay, now we're right. I'm jumping into your work. Great job, everybody. Okay, Emil, I forgot his name, has 10 quarters, 4 dimes, 6 nickels. Keep these numbers in mind. These numbers were chosen purposefully, and you'll see why soon. I'm going to give you a little bit of an extension once we get to the end. So I'm going to do A and B with you. I want you to do the rest on your own. Pause it. Keep working. Okay, so write a ratio for each comparison below. I'm going to get my trusty pen out here. Compare the number of dimes. So that's going to be the first number to the number of nickels. It's going to be the second number. I've got 4 dimes there to the number of nickels. Well, I've got 6 nickels. Nailed it. An extension activity? No, I'm not ready for that. Never mind. You could reduce it. Remember fractions? You can reduce it. Keep them equivalent. If you know how to do that, do that. Okay, I don't want to overload those of you who aren't ready though. Okay, let's look at number or letter B. Compare the number of nickels. That's going to be the first number to the number of dimes. So nickels, 6 to 4 dimes. Okay, pause this. I want you to do C, D. I think it's C, D, and E. I want you to do the next 3 on your own. Quarters to dimes, dimes to the whole number of coins, and then nickels to the number of coins. Okay, give it a shot. Pause the video. Go to the next one. Hopefully you did pretty well with the first one. Let's look at number 2, same coin collection. So what we're going to do, this is the trickier part, we're looking at the value. How much is that coin worth? Where'd my pen go? How much is the coin worth? The value of the dimes. 4 dimes is how much? 40. Are you counting? 40 cents. And honestly, if this is too challenging to do it with the money, skip it because I don't want you to cry about your math. Don't cry about your math. Challenge yourself. Get a calculator if you want, but let's not do any crying, okay? To the value of the nickels. Remember, we're counting by 5s. 5, 10, 15, 20, 25, 30 to 30 cents. Now that's not so challenging, is it, to count? Okay, so compare the value of nickels to the value of dimes. Well, that's reverso. And I want you to write it in the opposite order. Compare the value of the quarters to the value of dimes. Don't forget when you're counting with quarters, it's by 25. 25, 50, 75, $1, 25, 50, 75, $2, 25, 50. Oh, that's $2.50 compared to the value of the dimes. 40. Okay, I'm doing all your work for you. I want you to pause the video and I want you to do the next questions, keeping in mind the value of the coins. Okay, when we get to number 4, I skip number 3. It's pretty self-explanatory. When we get to number 4, there's an important thing that for you to understand about ratios is that we can actually write them also in a fraction. So rather than writing them beside one another, and maybe that felt similar. So if I'm looking up here, if I compare the dimes to the nickels, that might have felt similar to a fraction. And all we need to do to write it as a fraction is throw it on the fraction line. So this is going to be our numerator. The first number is our numerator. The second number is our denominator. And I know for some of you, my class, for sure, you're going to be pulling that fraction stuff from the history books because we didn't get to talk about it this year. So dig deep, pals. Okay. So write a fraction for each comparison. The number of nickels to the number of coins. Okay, so count the number of coins. And we're going to put our nickels as our numerator. That's the top number. Okay. And then write a fraction. I'm just going to go to the next one. I really want you guys to be successful with this, but I'm going to go super fast here. So write a fraction for each comparison below. The comparison of the value of nickels to the value of the coins. Again, write a fraction. Now, after you go through all of that, these are the your turn questions. This is what I would normally give to you at the very end for you to work on independently. So write 4 ratios about this set. Don't forget, you can do part. Oh, come on, Miss Wilson. You can do part to part, part to whole, whole to part. Okay, lots of options. Okay. Then if we go to the next one, the 2-row wampum belt has rows of white and purple beads. In each row, there are 9 white beads and 4 purple beads. Write the ratios. Okay, and you got a nice picture to show you. And here's some kiddos. Which part-to-part ratio below describes this group of children? Then I've added 2 games. These are the Math Up games. I've activated the links. They're both card games. They're both things that you might need to print, but they're worthwhile playing. And I really want you to give them a shot. Okay, so that's your lesson for this week. I just wanted to pull up our learning goal. So hopefully at the end of this lesson, you feel confident saying, I can use a ratio to compare 2 numbers, and I can also describe any ratio situation using many ratios and fractions. Hopefully you're feeling good about that. Okay. After this next week, I'd really like to jump into percent. We're not going to dive too deep into ratio because we're only really getting through 1 math lesson a week. So if you can, hop on Khan Academy, do some ratio practice, see if you can dive deeper into the concept if you have additional time. Don't feel pressure to get that far if you're not ready. Okay. This should be a not very stressful situation. If you're feeling really overwhelmed, play a game. Okay, play a game or send me a message and let's work together on working through some of this. We can work in a meet together. Okay, so hopefully this feels intuitive. Hopefully this feels not scary. Remember, you're comparing numbers. We're looking at our fruit. We're thinking about our grade 6s versus our grade 5s. We're thinking about our grade 6s versus our whole class. We're thinking about all of our fruit versus the lemons. Okay? I believe in you. You can do this. Have a great week.